Solving quadratic equations. So far we've learned two strategies for solving quadratic equations. We can use the square root when an equation can be written in the form x squared equals a number. For example, if we had 4x squared minus 100 equals 0, we don't have to factor this. We can solve using square roots because the only term we have is x squared. Nowhere do we have an x term. So to solve this, we would add 100 to both sides. 4x squared equals 100. Divide both sides by 4. X squared equals 25. Take the square root and we could have a solution of positive 5 and negative 5. And we could solve that equation using square roots because we can solve and get x squared equal to a number. The other strategy is factoring. Today I want to talk about equations that cannot be factored. For example, if you have the equation 2x squared plus 9x equals 18. You can't solve this equation using square roots because you have both an x squared term and you have an x term. So to solve this equation, you need to get the equation in standard form and set equal to 0. So what are we going to do with this 18 to move it to the other side so that we have the equation set equal to 0? We are going to subtract 18. Make sure when you do this, you keep the equation written in standard form. 2x squared plus 9x minus 18 equals 0. This is the type of equation where you would try to factor. When you try to factor, you have a product, a times c, of negative 36 and a sum of 9. If you go through the factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, you see that you do have a factor pair, positive 3 and 12. Subtract to give you 9, since you're multiplying to have one positive and one negative to give you a negative. So this is the type of equation we would factor. We would then separate the middle term, 2x squared minus 3x plus 12x minus 18 equals 0, so that we can factor by grouping x times 2x minus 3, positive 6 times 2x minus 3. So we get x plus 6 times 2x minus 3 equals 0. Then we would set each factor equal to 0 and solve. So one solution, x equals negative 6. The other solution, solve for x, add 3 to both sides, divide by 2, x equals 3 over 2. So that's what we've done so far with solving equations. Not all equations can be factored. So we have another strategy that allows us to solve quadratic equations when they cannot be factored. This is called the quadratic formula. You should write down and learn that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. In the quadratic formula, b, a, and c comes from the equation ax squared plus bx plus c equals 0. So to use the quadratic formula, you still want to get your equation set equal to 0, and then you're going to use the coefficients and the constant as your a value, b value, and c value, and you're going to substitute that into the quadratic formula and solve. If we go back and look at number 1 and solve using the quadratic formula, we had 2x squared plus 9x minus 18 equals 0. So A is 2, B is 9, C is negative 18. Let's substitute that into the quadratic formula. Negative B means negative 9 plus or minus the square root of B squared, 9 squared, minus 4 times A is 2, times C is negative 18, all divided by 2 times A is 2. So you can see that the quadratic formula, once you've substituted, does require quite a bit of computation, and we need to use order of operations. The order of operations states that we need to simplify inside the square root first. So we need to do 9 squared, 81, minus 4 times 2 times negative 18. This negative times this negative is going to make it plus. And 4 times 2 times 18 is 144. So we need to take the square root of 81 plus 144. Be sure you follow the order of operations. You have to add before you take the square root because you're taking the square root of that answer. 81 plus 144 is 225. So at this point we have x equals negative 9 plus or minus the square root of 225, all divided by 2a, 2 times 2, which is 4. So if we follow the order of operations from here, we now see if we can take the square root of 225, and we can, since 225 is a perfect square. So we're left with x equals negative 9 plus or minus 15 divided by 4. This plus or minus is how we come up with our two solutions. We now need to separate that into two problems. X equals negative 9 plus 15 divided by 4 is one of our solutions. Our other solution, x equals negative 9 minus 15 divided by 4. When we add 15 to negative 9, we get x equals 6 over 4, which then can be simplified to 3 over 2. When we subtract 15 from negative 9, we get x equals negative 24 divided by 4, which simplifies to negative 6. So our two solutions are negative 6 and 3 over 2. When we go back up and we look at our factoring, we also got negative 6 and positive 3 over 2. So there are two strategies there to solve that quadratic equation. Factoring is much more efficient. However, not all equations can be factored. So the quadratic formula allows you to solve any equation written in the format ax squared plus bx plus c equals 0. When an equation cannot be factored, for example, 4x squared equals 11 plus 4x. So this equation is not in our standard form, and it is not set equal to 0. We can't use square roots to solve it because it has an x squared and an x term. So we can't get x squared by itself. X squared equals a number. So we're going to have to use factoring or the quadratic formula. So let's get it set equal to 0. We're going to subtract 11 and subtract 4x from both sides. When I do that from this side, I want to make sure I put it in standard form where my constant comes at the end. Notice I moved everything onto the side with the 4x squared because I wanted to leave the 4x squared as a positive. I always leave my leading coefficient as a positive. So you could try to factor from here and see what two numbers multiply to give negative 44 and add to give negative 4? If we go through the factor pairs of 44, 1 times 44, 2 times 22, 4 times 11, and do any of these have a difference of 4? No. So this is a problem where you would say this can't be factored, and up to this point you didn't have a strategy for solving. Now you do. Now you can use the quadratic formula. Looking at the standard form, the A value is 4, the B value is negative 4, and the C value is negative 11. So that's what I'm going to use to substitute into the formula negative B plus or minus the square root of B squared minus 4AC all divided by 2A. So when I substitute, I get negative 4, since B is negative 4, plus or minus the square root of negative 4 squared minus 4 times negative 11, all divided by 2 times 4. Now I need to go through the order of operations to simplify. So I'm going to start off with negative 4 squared is 16. A negative times a negative is a positive. And 4 times 11 is 176. 176 plus 16 is 192. So this right here simplifies to the square root of 192. Negative 4 simplifies to 4. So 4 plus or minus the square root of 192 divided by 2 times 4 is 8. So far that's my simplest form. 192 is not a perfect square. So our next step is to simplify the radical 192. So if you go back and think about how do I simplify a radical, I need to divide by a perfect square. I can try 4. It's divisible by 4. It's also divisible by 16. When I simplify by dividing by 16, the square root of 16 times the square root of 12 is the square root of 192. The square root of 16 is 4. So that's 4 times the square root of 12. You should notice that the square root of 12 still has a perfect square factor. So that is the square root of 4 times the square root of 3 is equal to the square root of 12. Bring down the 4. 4 times the square root of 4 is 2. 4 times 2 is 8. 8 square root of 3. So the square root of 192 simplifies to 4 plus or minus 8 square root of 3 divided by 8. Now I should notice that all three terms have a common factor and can therefore be simplified further. All three terms are divisible by 4. When I divide by 4, x is equal to 1 plus or minus 2 square root 3 divided by 2. So my two solutions in exact, if I was asked to leave them in radical form, my two solutions are x equals 1 plus 2 square root 3 divided by 2, and x equals 1 minus 2 square root 3 divided by 2. Those are my two exact solutions. If I was asked to estimate those, I would substitute into the calculator the square root of 3 times 2 plus 1 divided by 2. And I would get x equals, x is approximately 2.2. When I do the same thing for 1 minus 2 square root 3 divided by 2, x is approximately negative 1.2. And this would be my estimate. So these would be the solutions to this quadratic equation that could not be factored. You need to pay attention to square roots of negatives as well We will still see that with the quadratic formula, which means no real solution.